My name's Jackie. I'm the head of comms at iMOVE, and we're pleased to bring you this webinar today looking at safety, using CITS for safety in motorcycle use cases. So first of all, I'd like to acknowledge the traditional custodians of the land from which we're meeting today, which is the Bunurong people of the Kulin Nation here in Port Melbourne. I'd like to pay respects to the elders past, present and emerging. This webinar is intended to last an hour. We have a presentation from La Trobe University that will take approximately 30 minutes. You are welcome to put through questions at any time during the webinar. So you'll see a little Q&A function on the bottom of your screen. You can put the questions in there. We will tackle the questions when we get to the end of the webinar. So please put them through. I note that there wasn't an option to submit questions on the registration form, which was my error because normally I do that. So yeah, get them in there when they pop into your head, and we'll look forward to receiving them. So other than that, we will pass over to the person that you've really come to hear from. So I'd like to introduce Eric van Volpen, who is Deputy Director at the Centre for Technology Infusion at La Trobe University. Well known to iMOVE, been working with us for a long time, and I'm excited to hear him speak on this particular topic about connectivity and motorcycle safety. So Eric, I'll hand over to you and yeah, take it away.
Yeah, thank you, and thank you all for joining and making time in your day to listen to a summary of our connected motorcycle project. The project came about, was conceived in Queensland. In Queensland, as many of you suspect, I will know, they've done a large test bed called the Ipwich project, and that was a CITS project where they demonstrated the safety benefits of CITS for cars. After that project was successfully completed, they've decided and raised the question, so how would this work for motorcyclists? And that then became this project, how would CITS work for motorcyclists? And it's supported by iMOVE, for which we are very grateful. And TSC came on board also. So just a few words about the Centre of Technology Infusion. So we are at a university, but we don't teach. And generally speaking, we don't work with students. So we have a team of engineers that can put together prototypes. And we have a fieldwork team that then engages with end users to test that. And that's basically the two legs that we walk on. We have done CITS work for more than a decade. So we've connected trains, we've connected buses, we've connected trams. But this is the first time that we've connected motorcycles, so that was an exciting, very exciting project. I will just go through a recap. I'm assuming that all of the visitors to this webinar are familiar with CITS. I'm not going to go into a lot of detail. More, I'm going to go into what did we try to achieve, how we went about it, what are the main findings, and what we think should happen after this. First, a word about CITS. Yes, it's about seeing and being seen and leveraging the advantages of the technology of CITS, that it can look around the corner and can technically alert riders of things that they wouldn't otherwise see. Now, I also want to take this opportunity following a presentation of a safety advocate who works at the Transport for New South Wales. And he tragically lost his daughter in an accident. And he says, don't call it accident, call it a crash. And make sure that when you talk about statistics, that you highlight that each statistic is basically a tragedy of family, friends who lose somebody dear to them. And so each one is one too many. And with that, then here are those statistics. This is about crashes in Queensland. And we also had access to crashes in Victoria thanks to TAC. But in Victoria, they don't keep track of the causality. And here, the dark blue are crashes that are the motorcyclist's fault, so to speak. And the green or the light blue are crashes that are caused by other road users. And the first bar you see and the largest contributor, this is 10 years of data. So the large contributor is in curves where motorcyclists lose control over their motorcycle, and there are no other traffic or almost no other traffic involved. But in the three bars after that, which are the second, third, and fourth contributor to crashes, it's a head-on turning right, so on the same road but turning right. It's an intersection and it's a lane change. And you can see that it's more the cars that are at fault rather than the motorcyclists. And so that tells us that CITS is about seeing and being seen. And this is the kind of story that when we first presented it to motorcyclists, kind of make them enthusiastic about this technology because it helps them to create this visibility to other road users as well. The Car-to-Car consortium is active to apply this technology and to develop standards since 2002. The Connected Motorcycle Consortium, which we are part of, exists since 2016. And so it's an area that needs a lot more attention still, is a lot less developed than the car-to-car standards and experience. And this particular project was the kind of the first in this kind where at a large scale, different use cases were tested in real circumstances, near real circumstances with a large group of riders. So that's just showing that there's some work to be done to apply this technology for motorcycles. So what we try to achieve is we really think that this is a good technology and deserves momentum and deserves investment, and we want to stimulate governments and industry to keep the momentum. And the way we do that is by checking the feasibility, the desirability, and the effectiveness. So how ready is the technology? Do riders want it? And does it make riders react earlier? So there's a broad spectrum of objectives that we wanted to achieve with this project. And it's about creating confidence. And it's about, for the government and TMR and TSC, it's about understanding how can we introduce this technology once it's maturing, once it's ready to be employed. It took ABS decades to get accepted, and still riders are not convinced that ABS is beneficial to them. There's still riders who think that they can do a better job at braking than ABS. And it took many decades and to get that in a fixed position in the market. And so to overcome objections from riders was one of the other kind of objectives that we wanted to achieve with this project, to understand how can we get it adopted. So how did we go about it? We knew from the beginning that this project had to be co-created and had to be done together with riders. Riders have obviously a totally different motivation for going from point A to B than car drivers. It's a different breed of people, almost. It's a very strong community as we've learned them intimately. So we started with dinners in hotels that were frequently visited by riders, and we invited rider community to have a steak with us, one glass of wine, not more. And we explained the concept of CITS to them, and we explained ways how that might be communicated, and we asked them for some first reactions. And we did 3 of those in Victoria, and we did 3 of those in Queensland as well. And the participation was really, really good, and the interest was high. And from there, we snowballed on to a bigger group. We have now 600 of those riders in our database, and they proved to be really engaged with this topic, which is another kind of point of evidence that riders, you wouldn't get a group like that engaged with just car drivers. And in the end, all in all, we had more than 700 rider engagements. So in end 2003, we did our market research with those rider dinners, with quantitative research, We did a global research and search for ways how to communicate these warnings to riders, which is one of the challenges because they like to keep their eyes on the road. They don't want to be distracted. And so we looked globally at what technologies could help to deliver that warning. We then settled those and we developed them into prototypes. We developed a simulator that we could use to expose riders to real risk in a safe simulating environment. Of course, we enabled 3 motorcycles to communicate with other road users using a Coda MK6. And we developed the use cases both on the simulator and on the test track with the goal eventually, which happened in February 2005, to be able to give these riders a real life experience on the test track where they could experience these technologies in 5 different use cases, where we had cars simulating that they would not give them the right of way, which of course they did to keep it safe. But still they experienced these warnings on a motorcycle as it could look like in the future. We also then invited them to go to a simulator, and from the simulator, what we've learned, we could make the use cases a bit more risky. So if you make a mistake or if you don't react to the warning, you would get into a crash, and that then enabled us to check whether they would behave differently with a warning than without. So to do those trials to get empirical evidence about the desirability, about the effectiveness, and about the feasibility, that was the goal. We worked very closely together with the Connected Motorcycle Consortium. Two of the team went to Ducati in Bologna, and the regular interactions with the industry was important to us to make sure that in the end the results are accepted by the industry and that they are motivated by it. One of the insights of doing research with the riders about how to deliver these warnings is that they really want to know, okay, where is the hazard and how urgent is it? And that sounds obvious, but there's many different ways how to design these warnings. There can be information rich and there can be information poor. And we feel that these icons represent the right balance because they give the ability to show where the hazard is. And they also give the ability to say this is really urgent or this is just informative. And that then helped us to design the efforts, the warnings for 7 different devices. Motorcycles, of course, need to have this technology built in on the motorcycle, and 2 options for that are to communicate through LEDs on the mirrors. And that is what a few of the members of the Motorcycle Consortium are exploring. Using that insight from the previous slide, we adapted that to put LEDs not just on the mirrors for hazards that are behind the rider, but we also put LEDs on front of the dash to indicate, okay, it is in front of you, it's right in front of you, it's left in front of you. So that is kind of an on-bike option. Of course, we developed something on the dashboard, even though a lot of the riders indicated, well, I hardly use my dashboard, but there are, of course, riders who do. And for that, we developed an option. We worked very closely with Foresight Helmets, a very proud Australian company that got sold to GoPro. And they have an LED under the visor, and the LED can be programmed and can be green, can be red, can be blue, can be orange, can be different colors and different shapes and different patterns. So we try to use that as a warning device. And we also use the sound inside the helmet, which was really, really good. We had an option for maps for motorcyclists that use maps for navigation, and a warning would pop up just like a warning pops up for a speed camera. The wristband that vibrates for Motorbit, unfortunately, is no longer in production as there wasn't enough demand and the cost too high. But we did try it in our trial, and later on I will share the results. Then, of course, we developed voice warnings, and we worked with the same company as BMW does about smart glasses to kind of wear these smart glasses and have information in the periphery of your vision. So those were the prototypes that we've developed for testing. To communicate with these prototypes, we needed to have an Android app that was kind of the hub of communication when we talk about motorcycle integration. So, as I mentioned, we worked with Coda MK6, and that uses wiretaps and OBD2 to get information from the motorcycle, like the throttle, the brake, the blinker. And that information, then when the Coda unit decided, okay, it's time to trigger a warning, it communicated to our hub, and our hub translated that to the right warning for the particular interface that was being tested. And that is something that the industry then also needs to develop, because they need to have, according to our riders, an inbuilt version, but also a way to communicate these warnings using Bluetooth on the preferred device. This hub also communicated real-time data to our analytics backend. So all of the data was communicated and processed in real time, so we could get a good view from our central base. The picture in my background is that central base on the Toyota test track. And from there, we could see all the data coming in and whether the warnings were delivered successfully and what the reaction of the rider was. So that was our setup. And we used a Honda, the same motorcycle that all Australians learn how to ride motorcycling on. It's a very light, non-imposing and not very impressive motorcycle, but it's very safe and low barrier. So that was good for all kind of riders to test this technology on. And you can see the fit out with some 3D printed features sitting on the MK6 that we have integrated on the back of the motorcycle. We purchased a mechanical motorcycle simulator from Spain that had the same kind of interactions as the Honda MK6, of the Honda C125. And so we integrated that with an open source simulation package called Carla. We had to figure out how to make that left-hand driving, as for the moment there was only right-hand driving use cases on it. But that is a package that is used to test autonomous vehicles in various scenarios. And we adapted that to our motorcycle. So there was a screen in the front that represents what the motorcyclist sees, and there was a screen in the back that could be seen from the mirror view. And we used that to test our motorcycles, and the same on-bike warning systems like the LEDs and the dashboard and the Bluetooth are also integrated on this bike, just as with the Honda. And this simulator provided then perfect GPS data and location data to our MK6, which was on the loop. And the MK6 then provided the warnings as in a real situation. So these are the 5 use cases that we focused on. That was based on our accentology and also based on rider feedback and preferences. So forward collision warning is one of the scenarios. The intersection movement assist, where the car looks like it doesn't give right of way to the motorcyclist. The change of the road surface. A lane change assist, blind spot warning, and a dangerous curve warning. So those are the 5 use cases that we implemented. And we implemented in a way that riders could not anticipate which use case was going to be triggered when. And this is how we eventually, once we got all the data, determined whether it was effective. And to see whether it's effective, we would like to see that the rider reacts earlier with the warning than without a warning. And to determine that, we'd have to very accurately capture when did the rider receive the warning and when did he start changing his behavior. So on the left hand, you can see some graphs that we used to track the throttle, the brake, and the indicator, and this was all automated. and we captured the time that the warning was received, and we captured when there was a significant change in the behavior that resulted in a significant change of speed. And then our algorithm determined, okay, what is the exact reaction timestamp where the rider starts to react. And from that, we could then make the further calculations to see the difference between the reaction with the warning and the reaction without a warning. Right, so that's how we went about it. So what are the main findings? So first, as I mentioned, we spoke about the technical feasibility. We spoke about, do riders want it and does it work? So first, we talked about the technical performance. And in terms of the radio performance, we checked all of these metrics that are specified in the standards, and the radios worked really, really well. We, of course, have to say that this Toyota test track where we did the real-time testing there are no buildings, there's no trees, there's an open sky, so it's a really good environment to test this kind of technology in. But it did really well. So the latency was really, really low, up to 150 meters. And the packet distribution ratio was good until a few hundred meters as well. So there is no issue whatsoever in terms of that part of the technology. Here you can see the distribution of the warning delivery. In the blue is on the test track, and in the green it's in the simulator. And you can see that in the real perfect situations in the simulator, the bell curve is a bit narrower, it's a bit more accurate, a bit more reliable at the same time. There's more variation in the real test track, and that is as can be expected. We did notice that on the test track there were a few warnings missed where we expected them, and you can read more information about that in the report. I have to add that the product that we tested from Coda, the software is a test software, so it's not commercial grade software. That is hard to get your hands on as it belongs to the OEMs. But it still performed really well. But we also think that the algorithm development in complex road scenarios requires more work. Okay, now let's talk about the desirability. So at the beginning, when we did our quantitative research, just after we did the rider dinners, a lot of the riders were on the fence. So here you can see that 24% is on the fence and another 10% is negative. And clearly that could be explained by they didn't understand how it works. So the kind of questions that we answered, and I have to say that in Queensland, the groups were quite suspicious of the intentions of the government. And so they said, how are they going to use these data? If you give them data, how are they going to use it? Are they going to give us automatic tickets, or are they going to shut down our bikes if you go too fast? That was a little less the case in Victoria, but still, if people do not understand how the technology works, they also don't like it. So that was the main insight when we started out this project. At the end of the project, or in the beginning of this project, in our quantitative research, as you might expect, that the people who are conservative are more interested in safety technology, and the people who are more thrill seekers, who actually like risk, are a little bit less looking forward to this technology. And we'll keep those factors in mind, because at the end of our trial, we found 3 segments that have different kind of risk profile and different kind of adoption profile. So on the left-hand side, the axis says from 1 to 10 is, would you like this technology on your motorcycle? And the biggest group, 56%, who can be typified as they're experienced riders, they're very safety conscious, they're a little bit older, and those people, 56%, are really positive. The people who are less positive, or who are negative, are the risk tolerant, tech skeptical is how we call them. So they ride for the thrill of riding. They feel that the skill of riding is something really important, and the technology should not interfere with their skill. And they actually feel that all riders should focus on that skill, not on technology. So that's basically why they are not that positive. And frankly speaking, this 11% in our sample is small, but in reality, they're probably more like this, because if you're not interested in technology, you probably wouldn't come to a technology trial. So there will be some sampling bias in there. Interestingly, we found a third segment who are kind of interested in the thrill of riding, who are young sporty commuters, that's what we call them. And they're 33%, and they are positive about this technology. And one of the main motivators is they say, well, this technology is around for cars. Why wouldn't it be for motorcycles? It's time that the motorcycles kept up with the technology development and catch up on the safety features that cars have. So that was their motivation. Now, in order to kind of thinking from the government perspective, how would they get this skeptical group still on board with this technology to accelerate the adoption? So this diagram shows the light blue, the dark blue, and the green diamond. And the green diamond is that negative segment. So you can see that they have lower desirability, more riding risk, are a little bit younger. But the two factors that really matter are the warning integration and the warning usefulness. So let's quickly look at each one of them. So the warning usefulness, here you can see how useful each segment thought that the warnings was in the various 5 use cases that we trialed. And you can see on top is the average across all use cases, and you can see that the tech skeptical riders scored the lowest, significantly lower, 5.21, compared to around 7 of the other 2 segments. But in that, you can see the light blue square with an 8.6 score, and that's the intersection warning. So while on average, these tech skeptical riders didn't appreciate the warnings that much, they didn't think they were that useful. In this particular use case, they did think they were useful, and they thought even more so than the other 2 segments. So that gives a clear inroad for governments and industry to communicate with these people to focus on this particular use case. Then about which warning delivering is most preferred. Well, mostly the main factor was, does it distract or not? And some of them distract more than others, but that's the reason why helmet audio was so popular. And the way we tested this is a little bit different than traditional market research. We wanted to simulate a real market where we didn't want riders to choose one way of communication of warnings that they wouldn't choose normally in life. So we let them, except for the things that were on bike, like the LEDs and the dashboard, they were given to everybody, but all the riders could choose their favorite way of communication and then use that in the trial as they went around the test track. And so a lot of them chose, and that reflects how a market would work too. So a lot of them chose to experience the helmet audio and also preferred that then consequently as the best way to receive these warnings. The LEDs on the mirrors and on the front of the bicycle were number 2. And kind of surprisingly, the wristband was number 3. And the reason for that is that the riders do not need to take their eyes off the road. And they were very happy with that. And they also had a feeling that because it's just a sensation, it doesn't take any brain power, so you can react faster. The helmet visual, which is the LED, was not that much preferred. The dashboard smart glasses and the map, only a few people chose them, so they were not preferred at all. Now, I've been talking so far, but we've also have some riders who give their opinion. So let's have a listen to them.
Vehicle on left. Vehicle on left. Forward collision warning. Rough surface ahead.
I think about it every time I ride, basically. Pretty much every single time I commute to and from work, every single time I ride, I have someone do something stupid in front of me, and something that puts me kind of in harm's way. And yeah, it makes me nervous.
It was great. I got to ride my motorbike here, and I say any day that I get to ride a bike is a good day. It gives you your freedom, but coming in here and helping out, making our community a lot more safer. And I call it a community because most of us wave and nod and say hello to each other, and we talk to each other. So anything I can do to help us stay alive and in one piece is good.
Yeah, I think anything that gives a rider more time to react is absolutely beneficial. You then have the opportunity to be aware of what it is, react to what it is, rather than becoming part of that issue.
I don't quite like the warning devices on the bike. I find them a bit distractive. I would prefer talking to me in my ears.
I ride professionally, confirming what I can see, so you can see where it can work really, really well. No, I can definitely see it being something that's added to bikes as part of the ADRs or something like that down the track to assist with, trying to wind the fatals back. Look, it's a great concept. Obviously some tweaking can be done here and there in relation to like colours to differentiate between a turn and an obstacle or something like that. But obviously being a trial phase, those sort of things can be worked out. So
this is going in the right direction. It's giving us as riders the opportunity to be safer and to use the tech as we need. So I think this is really, really good. And what you guys are doing in a safe environment here, it's amazing.
I think it was really good. I was pretty surprised at how sophisticated it was, to be honest. And I think that the work that's being done here is really important. And I think with technology evolving and stuff like that, it's kind of stuff that needs to be done now. So then in the future, when we've got kind of the automation of vehicles and stuff like that, it'll be able to be integrated really easily.
I think it's incredible the amount of time and effort that's been put into potentially bettering motorcyclists whilst they're on the road. There's nothing on the market at the minute that provides that level of heads up or that level of additional safety for a rider. I'm really excited by it. I think it'd be fantastic.
Right, so the question that we haven't answered yet, does it really work? And in order to do that, as I mentioned, we tested the same use cases with warning and without, and we checked the hypothesis was that, of course, with a warning, they would start reacting earlier. And that's also what we found. So the evidence that we collected says that, for instance, in a forward collision warning, there's 1 or 2 car lengths more distance to react, and that can really make a difference. So in another use case where it's about the intersection, that use case was really difficult. So it was really difficult for riders to see the car coming. That's why you see the initial reaction without any warning is very late. There's only less than a second to react to the particular hazard. But with warning, they started to react 2 seconds earlier. And so that can really be the difference between having a crash and not having a crash. And in terms of the curve, same, without warning, they started to react quite late, less than a second before the actual curve. happens, and 2 seconds added to that thanks to a warning. So this is evidence that has not been done because quantitative research with large groups of motorcyclists hasn't been done. And so this is the first time that shows, yes, it can actually avoid crashes. So the question is now what? And now what has to be collaboration between governments who can work on the standards, who can work on the data, who can work on the infrastructure already. It's of course about the industry to accelerate the development. So just recently, Honda has announced a timeline for integration. This and it's 2027, 2028. But Honda is a very significant kind of player in the market. So when Honda starts, then many times the others also follow. Very self-serving, but universities do have a role to play in terms of to bridge the innovation and the implementation. And the most important thing is what we wanted to achieve is from riders and from the market to ask for this kind of technology and to create demand for it. We are very lucky that we have now a follow-up project which is funded by the Victoria State Government and the Motorcycle Safety Grant. And that's what we're working on right now, where we change the perspective. So instead of looking at it from a motorcyclist point of view, now we're looking at it from the car driver's point of view, and to what extent this can help raise the awareness and reduce the crashes that are caused by cars. So the use cases that we are testing are different and are more about the visibility from a car perspective, that they don't understand or they don't see this motorcycle coming. So I want to thank TMR, TAC, iMOVE for the trust. All the riders have invested a lot of time. Toyota's test track is phenomenal. The service that we received there was great. We were there from 8 in the morning until 8 in the evening, and they were there and make sure that we were fed properly. So the service level is there, is great. And then lastly, our team and iMOVE, this kind of project, some people have the misconception that when you work for a university, that you're home by 5. That's generally speaking anyway a misconception, but particularly with this project, we had a lot of challenges to overcome. And I'm very indebted in the team to make that happen in the project period that we had. So that's all I have for you at the moment, and open the floor for questions.
Thanks, Eric. That's great. Fantastic presentation. And I did attend one of the demonstrations at Toyota as well, and it was really well run. So thanks for their support, and obviously TAC and TMR as well. So it was a really good collaboration. There's a few questions coming through. You've still got time to pop some through and we'll start tackling them. I did have one of my own, just as I'm going to selfishly just ask my question first. So just as you were going through, I noted that you mentioned the 5 use cases that you were testing. Was that, and the riders were involved in that whole process of deciding which ones should take priority. Were there other use cases that you would have liked to have tested? I assume there were more than 5 that you had to kind of rank, and were you sort of constrained in how many you could test?
The test track is 1.1 kilometer long, or 1.4, or so there's some constraints in that. There's time constraints. Each use case need to be tested and need to be developed. But for future use cases, we would like to be able to test some more complex use cases where there's more traffic and more road users involved. And that's how we see should be a priority for future work.
Yep. Okay, so it looks like there's plenty of potential there to do future work. So we've got a few questions coming through in the Q&A, and I think you've semi-answered some of these already, but we'll have a look at them anyway. But I particularly love the first one because it's sort of how can data feed back to create yet more value. So the question is, in addition to CITS being used as a real-time avoidance warning system, is there also an opportunity for technology and data generated to loop back into the rider and driver education. So how else can the data add value?
Well, so the concept of rider feedback and capturing riding data and use that for education is one that is currently being developed by a few players that are interested in making sure that the education of riders when they first start is better. Most of the electric motorcycles now have advanced data capture systems, and they have your own riding app that can analyze your own riding behavior and then give feedback to riders into this is the type of rider, or this is how safe, or this is the accident that you nearly missed. So that is under development. I would say that CITS is not a crucial element of that particular feedback because it adds some information, but most of the information can be obtained from the bicycle itself.
Yeah. Okay. Thank you. So relating to the different, the way that the information was passed around, we have a question about the use of mobile phones and coverage as part of the solution. Was that a problem?
Right. Well, this solution doesn't rely on a mobile phone app, actually. So the radios that are integrated into the motorcycle communicate directly without the internet or without mobile phone network with each other. And so there's no reliance on that part. The mobile phone only was used to communicate on the short distance between the motorcycle and the helmet, for instance, or the motorcycle and the smart glasses. So that's what the Bluetooth was used for. So yeah, the network and the internet and provider network doesn't impact the CITS solution. That really the MK6 communicates directly with other road users.
Yeah, thanks, Eric. And I think given that motorcyclists do like to go for long drives in remote areas, that's probably it's probably a good thing as well. So it was just the Bluetooth communication that it was used for. Just looking at, so you referenced it before talking about Honda, but do you, in terms of the integrated rider safety features, do you want to elaborate a little bit on the kinds of things that are becoming available for riders to use?
Sorry, say it again. Sorry.
So with the rider assistance safety features that are becoming available on motorcycles, I think you mentioned before about Honda and that they're starting to integrate some of these features. You didn't, in terms of what kinds of features will be available in motorcycles as newer motorcycle models as they become available,
Yes,
is that similar to the use cases that you're presenting here today?
well, there's an interesting story. So the head of the Ducati club in Melbourne, his name is called Simon. He bought the latest Ducati that came with a back-end radar, so it looks backwards and it warns you of upcoming hazards. And when he told his club members about that, they said, "You don't need it because nobody drives faster than you." And in fact, he called his son and said, "Okay, this technology I want to get rid of." So his son has a bike shop. Says I'll come by and then please have this technology removed from my motorbike.
Mm.
But then a few weeks later, his son called him and said, "Hey, are you coming?" I said, "Well, it's kind of useful to see what's coming up, and so I think I might keep it."
Mm.
But so those are the kind of technologies that you now, expect in the more expensive bikes,
Yeah.
where there's radars, lidars, and warning you of hazards.
Yeah, okay. And looking at the work that you did, you clearly identified different kinds of riders and what types of technologies they may or, what the buy-in was like. Obviously, with a new model of motorbikes, they're likely to be come with default settings that may not work for everyone. And as we know from cars, not everyone always uses those safety technologies, as your story illustrates as well. So looking at the remaining questions that are coming through, I'm going to paraphrase this one because it's more of an essay than a question, but really the question revolves around mandating V2X technology to save lives, which it looks like is already happening in China. So it's a little bit away from the actual research, but Eric, have you got any response to that question or knowledge about what that looks like with government?
Yes, well, that's how ABS now is mandated for new motorcycles. It's going to go that way. So it's necessary to have the government say you must do this because the penetration of this technology is a critical factor. Everybody needs to have it, and there's only one way to do it. It's by mandate.
Yep. So with the riders, we mentioned before that there's different levels of enthusiasm for technology and such like, but I think what all humans have in common is how much cognitive load they can cope with while they're riding. Did you find that it was overloading people in certain scenarios or delivering information that perhaps wasn't the most useful at that particular point in time? Or I guess when you were designing this, that you would have taken that into account. But the cognitive load aspect of it, I know when I drive a car, sometimes I'm like, oh, what's beeping now? Did that come up much?
Yeah, absolutely. So that is a very, very important factor for the adoption of this technology. So there's grave concerns about having warnings all of the time in your ear, where they're not really necessary. So that is something that also needs further development to make sure that there's no false positives or no false negatives. And that is one of the top concerns that riders have, and rightfully so. And the other is that we first had our curve warning dependent on the angle of the motorcycle. So if the angle of the motorcycle, according to the algorithm, was unsafe, they would get a warning. And motorcyclists were very clear and said, at that point, I don't want to have a beep in my ear. I'm taking a curve, and I don't want to have this information. And so the third point is I alluded to in my presentation that there are various ways how to communicate these warnings, and some brands are having very detailed icons that show you what is the kind of hazard that you are facing. And motorcyclists in our study said, no, we don't want that. Just show us where it is, and then we'll deal with it.
Yeah, that's the complexity of individual preferences and, what people really feel is essential to their riding safety.
But that concept of cognitive overload is an essential one to understand for motorcyclists because they need to keep their attention on the road and what's happening. And they are very proud of having that ability.
Yep. Thanks, Eric. Question from Marilyn. Were there any suggestions related to improving the audio output for the hazard communication system? And if so, what were the suggestions?
Well, the fact that it was raised as the most popular kind of warning delivery device, the most preferred, is we got it quite right. We did it quite well. And we didn't get much negative feedback other than people saying, hey, I might be listening to my music. Is there a way to interfere that? And I guess that can be done. So if people do listen to the radio or to streaming music while they're riding, that can be interrupted. And then, of course, the questions again about these false warnings and these false positives and false negatives come into play. If you're listening to music and you hope to have a relaxed ride and it's constantly interrupted because there's a small chance of a warning of a hazard there, a small chance of a warning there, then that is not a great experience. So that is something where the balance needs to be struck.
Yep. Okay, thanks, Eric. Just in terms of adoption of the technology, a couple of questions that have come through that are looking at this in different ways, but one more general about what are the chances of a wider adoption of this type of technology? And I think, you know, that might play into the answer you gave before about whether it's mandated or not. And is there an appetite to introduce the technology to the Australian design rules or NCAP ratings?
Yeah, we are in the current project, we are working with NCAP, and NCAP now, from a car perspective, tests whether their ADAS system detects motorcyclists, right? NCAP at the moment doesn't have an NCAP rating for motorcycles because it's too hard to do, but they're working on it. And I guess that the introduction of these features would help to determine, okay, to say this is a safe motorcycle and this one is safer than others. Could depend on these features. At the moment, it's very hard for NCAP to say this motorcycle is safer than others because they lack safety features.
Yeah. Okay. Thanks, Eric. I know we've got quite a few government people on the webinar today, but in terms of how government can support these kinds of initiatives and make things safer, what does government need to be doing to help make things safer for motorcyclists in terms of CITS implementation and technology?
It actually ties into your previous question, will it be adopted? And the government's role often is to take the high risk investment, right? So there's a commercial aspect to it that the industry needs to solve. But at this stage, the technology is still quite frail, and there's a lot of development that needs to happen. There's a lot of parties that need to come together. And typically, if it's a promising technology as we think it is, that's where government steps in and stimulates the investment and stimulates the development up to a point where there's critical mass and it takes care of itself. So that's what I feel that the role of the government is, to make sure that the background work is being done in terms of making data available, and that is being done in another iMOVE project where they are collecting data like in a national access point from all of the curves, from all of the road changes, and they're working to make that safety data available in a consistent manner. So it can be delivered in these kind of use cases, and that's an example of how government can start prepare and setting the regulation and standards, and then stimulate development, stimulate the industry in where the risk is still a bit high.
Yep. Okay, that's great. Thanks, Eric. And I think you mentioned before that you're now working on a new project, which is basically looking at how cars can adopt safer behavior towards motorcyclists. So it's looking at it from the other angle. And you presented some information previously about, you know, cases where the motorcyclist was at fault and other cases where it was more the car that was at fault. What's the kind of sort of, how do they complement each other, and what kind of tensions are sort of between those two sides of the challenge?
Yeah, so here what we are trying to do is the same. A lot of cars now have safety features. They have this ADAS, and in this case, it's about what our hypothesis that CITS is a useful addition to that radar, lidar, or camera technologies, because it can look around the corner. So the use cases that we are testing now are having to do with motorcyclists being out of sight for drivers, and then giving the driver a heads up. Now it's slightly different aspect because our research shows that even when car drivers are made aware of motorcyclists, sometimes they still get into an accident. And that's because they don't understand the behavior of motorcyclists. And so with this project, we want to test that And so we have half of the participants will be driving a car and a motorcycle. And because they drive a motorcycle, they understand that. And then we test the same use cases with drivers who do not ride a motorcycle. And we try to see that the difference is education and the difference is understanding of the behavior of motorcyclists. It's not only about awareness, it's also about making the right decision and being made aware of. So there's quite a few cases where motorcyclists tell stories of, I looked the driver straight into the eyes, he saw me and still didn't take action. And so that is something that we're trying to address in this project.
Yeah, thanks, Eric. That's really interesting. I'm looking forward. We will run a webinar later on the second project as well, I hope. So we'll be able to have some more definitive responses, information around what was learnt there. So just in terms of one final question, for you, what, returning back to the original project, the CITS for motorcyclists, what was the biggest finding that would impact on how we think about motorcycle safety?
Well, the biggest finding is that motorcyclists actually want this. So the majority of them do want this. And it has never been tested with a large group of motorcyclists. Most of the time, they're a bunch of engineers doing engineering stuff, right? Showing that it can work. And this is the first time globally that hundreds of rides were involved in the development. And the majority of them actually want this technology. So that's the main message. We didn't know up front, right? So we knew that there is some ambivalence with ABS, and that there's a small group of riders who are still ambivalent, not convinced that this is a good thing. Therefore, we wanted to check, okay, CITS, do riders actually want that, or do they think it's a nuisance or don't need it? It was a question mark, but that is definitively answered now. As is, would it work? Do they react better? And they do. So that evidence has been delivered, which wasn't available before.
Oh, great. Thanks, Eric. And as a friend of people who ride motorbikes, thank you for the amazing project that you've delivered. And we hope to see adoption and uptake from here. So just to wrap things up for this session, we have recorded this webinar and we will make it available online on the iMOVE website. A few people have asked that question. And obviously, if you have any further questions, very happy to put you in contact with Eric after this event. So we look forward to doing the second webinar, looking at the outcomes on your project with cars and looking at how the driver behaviour and education can play a role. So Eric, thank you so much for coming and talking to us today. I think it's important that we get this research out there, and I appreciate you taking the time. So thanks very much, and thank you to everyone that attended today. We look forward to seeing you on the next Project Outcomes webinar. So bye for now and see you soon.
Thank you.